In 1.3 million years, a star will enter our solar system. It will miss Earth and the Sun. But its path crosses the Oort Cloud, where its gravity may push distant comets onto entirely new journeys. This is Cosmion. Point it at any question in the universe, and it will show you the answer, whether you can bear it or not. Tonight, we point it at GJ 710. It looks like an ordinary, faint star. Its movement is anything but ordinary. GJ 710 is an orange dwarf star, class K. It has about 6/10 of the Sun's mass and produces less than 1/10 of its light. Right now, GJ 710 is about 62 light-years away. At that distance, its weak glow gives no obvious warning of what its motion reveals. Watch GJ 710 against the stars behind it. Its position barely shifts sideways. That tiny movement makes it look almost fixed in the sky. Now split its starlight into a spectrum. The light reveals motion towards us at about 14 kilometers every second. GJ 710 is not standing still. GJ 710 barely moves sideways while traveling quickly towards us. Put those motions together, and its predicted path passes unusually close to the Sun. ESA's Gaia mission measured the star's position, distance, and tiny movement across the sky. Ground-based spectra measured how quickly it travels towards us. The 2026 study corrected small shifts created inside the star's own atmosphere and gravity. Those corrections sharpened the speed used in the calculation. The calculation carries the measured motion forwards. GJ 710 and the Sun continue along their paths until the distance between them stops shrinking. This is a model prediction, not a fixed appointment. Every measurement carries uncertainty, but every path inside the current range still brings the star unusually close. The latest calculation places closest approach roughly 1.34 million years from now. The encounter lies far beyond any human lifetime. At closest approach, GJ 710 is predicted to pass about 12,800 astronomical units from the Sun. Neptune circles the Sun at about 30 astronomical units. GJ 710 remains more than 400 times farther away than Neptune, even at its closest. On a stellar scale, a little over 2 light months is an extraordinarily close pass. The empty-looking distance beyond Neptune may contain the Oort Cloud. This is the proposed reservoir of frozen bodies surrounding the Sun far beyond the planets. No telescope has photographed the Oort Cloud as a cloud. Astronomers infer it partly because long-period comets arrive from every direction, not from one flat plane. Using the study's model for the cloud's outer edge, GJ 710 would spend nearly 70,000 years crossing it. This is not a brief brush past its edge. GJ 710's flyby speed is about 14 kilometers per second. The typical encounter in the new study is more than 4 times faster. Gravity becomes weaker with distance, but it never switches off. For a comet already far from the Sun, even a small extra pull can matter. Start with one comet on a long orbit around the Sun. The Sun's gravity keeps it bound. Then GJ 710 approaches from the side. As the star draws near, its gravity pulls the comet sideways. The comet leaves the encounter with a slightly different speed and direction. That small change reshapes the whole orbit. The comet may fall closer to the Sun, move farther out, or escape into interstellar space. An inward turn does not send a comet straight to Earth. The comet must still cross an enormous distance. That journey may take hundreds of thousands of years. The Oort Cloud's population is not mapped object by object. Its boundary is uncertain, and the closest comets to the star's path are unknown. Models can show that some comet paths may change. They cannot name a future impactor or give Earth an impact date. That distinction matters. Researchers have looked for a clear link between stellar flybys and periods of heavier bombardment on Earth. So far, that clear link has not emerged. The 2026 paper does not simulate a list of future comets. It calculates the star's path and places that encounter among other stellar flybys. The closer a comet passes to the star, the stronger the pull can be. Comets far from its track may change very little. The changed bodies do not leave as one wall of ice. Each comet begins from a different place, with a different speed and direction. GJ 710 also takes nearly 70,000 years to cross the modelled cloud. The gravitational changes begin at different times throughout that long passage. By the time an altered comet reached the planets, GJ 710 could be far away again. The cause and the visible consequence may be separated by ages. So the honest prediction is a changed reservoir, not a dated apocalypse. The star's path is measurable. Every individual comet outcome remains uncertain. So, is a star heading into our solar system? Yes. GJ 710 is predicted to enter the solar system's distant proposed comet cloud. It will not enter the realm of the planets. It will miss the Sun by more than 12,000 astronomical units. Earth is not in its path. The real encounter happens at the solar system's weakest edge. There, the star's gravity may redirect some comets and eject others completely. An encounter this close is rare. The new study places one at roughly every 50 million years for a typical star in the local neighborhood. Less extreme stellar passages happen far more often. Using that same modeled boundary, the study estimates around 12,000 flybys across the solar system's lifetime. Most individual encounters make only small changes. Over billions of years, those changes accumulate. Comets are traded, redirected, or lost to interstellar space. From Earth, GJ 710 would no longer look faint. Models suggest it could become one of the brightest points in the night sky. Its position would also change fast enough to notice across a human lifetime. Future observers could watch a nearby star cross the background sky. Then the separation starts growing again. GJ 710 moves on through the galaxy, taking its gravity with it. The changed comet paths remain. The solar system is not a sealed machine. It travels through a galaxy full of moving stars. Its distant edge is constantly meeting that wider environment. GJ 710 will not bring a stellar collision. It may bring a slow rearrangement at the edge of home. That is quieter and far more real. One known star may already have crossed this distant frontier. Scholz's star passed near the solar system about 70,000 years ago. Subscribe to Cosmion. Next, we trace that earlier visitor and ask whether its gravity left a fingerprint we can still find.